All right, well, good morning. So, in this video, I want to discuss or at least look at uh, the difference between a relation and a function. Functions is going to be like the main topic that we're going to look at here, and there's lots to talk about, a lot to talk about. So, in this video, I've got uh, four relations or relationships, ways that you might represent a function. All right. So this right here is going to be a mapping. So I've got, this is, I guess, a random sample here of engine sizes. So, you get a little Toyota 1.8, the Ford 5.0 liter, and the Chevy small block, the 5.7. And we're going to pair these up to that vehicle's miles per gallon. All right, so most 1.8 liters might go to 35 miles per gallon. But maybe there's some kid out there who's you know using way too much gas and not being wise about the way he brakes and stuff, and he's only getting 20 miles per gallon. Your typical 5 liter might get 20 miles per gallon, so the 5.0 is going to go to 20, and your 5.7 probably going to be going to the 15 miles per gallon, but it may also go to this 20 miles per gallon as well. All right, so we're pairing the engine size to the miles per gallon. Now, a relation is just a pairing of inputs to outputs. All right, and here you can see we've paired the engine size to the miles per gallon. So these are like my inputs, and these are kind of like my outputs. All right, so I'm saying the 5.0 goes to the 20, the 5.7 goes to 20, and it goes to 15. Now, a function is a special relation. A function is where you have each input going to exactly one output. So this right here, where the 5.7 goes to two different places, or the 1.8 liter going to two different places, that tells us that this mapping, that relation, is not a function. Okay? Because you had one input that went to two different places, and that breaks the rules for what it means to be a function. Okay? This little graph here, chart, I've got what this represents is I'm walking, around my room here, around my classroom, and it's going to take me, 20 seconds to walk around it. All right, and what I'm doing is I'm measuring the distance I am from the door at any given moment in time. So whenever I first start, I have time zero, and I'm also a distance of zero away from the door. At 5 seconds, if you follow that up, so at 5 seconds, I am 26 feet away from the door. So I'm walking around the room here, and at 10 seconds, I am now at 30 feet away from the door. And you can see that that's the furthest distance that I'm ever away from the door. And then at 18 seconds in, I'm then at 7 feet away from the door. And at 20 seconds in, I am back to where I started. So I'm right there next to the door. Okay. So now in this example, time would represent my set of inputs, and the distance I am from the door, that would represent my set of outputs. In this case, this is a function because 5 pairs to 26, 10 pairs to 30, 18 pairs to 7, and 20 pairs to 0. Now 0 also pairs to 0. So the reason that this is a function is because each input, these parts, they only pair to exactly one output. All right. Uh, at 18 seconds in, I'm not 7 feet away and 15 feet away. All right. That doesn't happen. At 5 seconds in, I'm only 26 feet away. I can't be in two places at once, basically. All right. Now, the fact that I'm 0 feet away at the 0 and 20-second mark, that's okay because these inputs are just going to the same place, all right? But like at time 0, I'm not in 2 different places, all right? So this is a function, all right? This graph is a function. You can also have a set of ordered pairs, okay? So this represents like a classroom of a few kids here, where I'm looking at their age. So the first number, the X value here, the inputs, and that's the teacher. This is their age. And the second number, the Y value, those are the outputs. This is how tall they are in inches. So the teacher is 63 inches tall. So if you look here, 5 goes to 40, 4 pairs to 35, 30 pairs to 63, 4 pairs to 38. That is our first indicator that this is not a function, all right, because the 4 is going to 35 and the 4 is going to 38. Remember, these first numbers, those are your inputs, right? And because you have the same input going to 2 different places, it is not a function. All right, and you'll also see 5 goes to 40 and 5 goes to 38. So this breaks the rule for being a function. All right, last example here, I've got a little t-table, and this is like the buttons you would press on, what do you call those things? Geez, a vending machine. The buttons you would press on a vending machine to get a certain snack. So if you press A2 or A3, you're going to get Cheetos. All right, so this column here, that would represent my inputs, and then the snack that you get back would represent the outputs. All right, so you may be able to get Cheetos out of two different ways here, but that's okay. To be a function, right? A function is something where each input goes to exactly one output. So if A2 went to Cheetos and Kit Kats or something, that would mean that it would not be a function. All right, no one wants a vending machine that's not dependable. Like if you press B4, well, probably not sliced apples, let's say C5. If you press C5, you should always get Doritos. That's what it means to be a function. It's predictable. All right, you can predict the output based on whatever button you press.